intensity.
It's absorptive power, emissive power. We'll talk later on. जो तुम कह रहे हो, that can be also a black body is a body which is capable of emitting radiations of all wavelengths, all frequencies, and it can also absorb the same wavelengths. Now, as he said that if we plot a graph between the intensity of black body radiations, I write here I. You see, intensity is energy given out per unit area per second. याद रखिएगा. Okay? It is standard definition. Intensity is energy given out by per unit of a body in 1 second in a unit time. You can take the unit system. So if I put a intensity versus suppose I want a black body, I have heated it, and it is what is the real black body that I take later on. If it is a black body, it has been heated to extremely high temperature, let us say T, and now it is giving out radiations. You can see it is red light. Suppose you have heated it to a temperature, it gives a red. It not only red, besides red, it gives all other radiations. Our eye can see only. So if you plot a graph, whatever if I plot a graph between the wavelength and intensity, if you just reverse the graph, it will become frequency and the because wavelength is just inverse of that. That I tell you how to do it. So if you put a this is a wavelength. So what does it mean? If at any temperature you will note here is a sharp peak, it goes like this, it goes like this. This is let us say a temperature T1. So if you have got a spectrometer or any other method which can measure the frequency or the wavelength of the radiation given out by a body, the body is at a constant temperature T1, you are able to measure the intensity also, energy given out at a particular frequency. You will get a graph like this. What you are noting that this is lower wavelength, 0, and from 0 wavelength goes on increasing like this. So you should know. If I don't put arrows here, I should put arrows here to say what is happening with the wave. So wavelength is increasing like this. You know that at further lower wavelengths or higher frequencies, okay, you find a steep increase in the intensity. Intensity becomes maximum at a particular wavelength. This wavelength we will call lambda m or max. So lambda max is a wavelength corresponding at a particular temperature at which intensity is maximum. Have you understood? Every black body is capable of giving. Now suppose I heat it from T1 to T2. What will happen? The graph will shift like this. This lambda will shift here. So you have to be very particular in drawing the graph. So this is T2. From T2 you can see again this lambda max for T1 for lambda maximum for T2 has shifted here. Can you see this thing? This is lambda max at T2. This is lambda max at T1. What does it mean? Wavelength has, what has happened? Wavelength has decreased, so frequency has increased. That is why when you take any body, you start heating it. It first becomes red. After the red, if you go on heating it will become blue. It has to. Because the blue color has got less wavelength than this. So this is at a particular temperature. Now, three very, very important laws are here which you are supposed to know. This is called laws of black body radiations. I read VBR so that you come to know. First law is called Stephen's law. What does it say? This law says energy given out is directly proportional to fourth power of the temperature. This is very, very important law. Or if you say energy is some constant into T4, temperature is absolute, then this energy is equal to sigma into T4. इस पे आपका numerical आ सकता है. You will get a numerical on this. Stephen's constant they will give you. You can see its energy raised to the power by 4. Okay. Energy given out per unit area per this is effective intensity. So energy given out by a body in a unit area in a unit time is directly proportional to the fourth power of the temperature. This is called Stephen's law. This is called Stephen's constant. इसकी वैल्यू आप लोग बुक पे देखिए. Try to know this. This is one of the. Now, how to show this here? Now, this energy given out at any temperature by a black body is by the area under the graph. Okay? Can you see the same? If I ask you, where is the energy per unit area per unit second? So you can say, at this particular you say, the entire area under this graph gives the total energy given out in a unit second by unit area. Total energy. You have to check unit area or not. You have to check it. Please check it. Whether it is unit area or the entire area. I think it's the entire area in a unit second. So the intensity energy will be energy per unit second. Because I don't think it can be a unit area. Please check it. You check it. Second law, which is very, very important. So this is your first law. If we just compare this graph and this graph, you should automatically be able to tell me the area of this graph T2. If how many times T1? If T2 is twice T1. If T2 is twice T1, double the temperature, it's an absolute, is it okay? Then this area will be how many times this area? This is one number question it can come. But I
2
very good. Very nice. What? How much it will be there?
2 raised to 5.
How much is that here? What is 2 raised to 4?
60.
Yes, automatically this graph area should be 16 times. Because I told you, you have to equate. Let this be E1. So this is equation. Let this be E2. E1 with T1, E2 with T2. Divide E1 by E2. Sigma sigma will cancel. T1 by 4 upon T2 by 4. If T1 by T2 is 2 or 1 by 2, automatically you will come to 16 times. So this is one of the direct consequences. Second law, which is very, very important, is called Green's displacement law. Numerical also can come on this. Green's displacement law. What is that law? If I ask you which of the, this is the second law I am telling you. What is the second law? This is called Green's displacement law. EI is called, we have the name here. I write displacement. This is law. This is simple. Lambda m into t is constant. Here the thing. They can give you a question on this also. Simple. Okay. If I ask you which of the stars is hot star, hotter, a blue star or a red star? Blue. Why? You can use this.
Yes.
Okay.
Yes.
We can give you the Wien's constant. This constant is called Wien's constant. You can see it is meter into Kelvin. Okay. You will always take the value of this constant. This is called Wien's constant. In the book they can give you the Wien's constant and they will tell you find the maximum wavelength corresponding to temperature in a black body spectrum. This entire thing is called a black body spectrum. Okay. This is the second law, which is very, very important. Third, which is not a law. If I ask you what is the characteristics of the black body spectrum, its characteristics is that if we plot a graph between the wavelength and the intensity or the energy, then we find that the intensity goes on increases as wavelength increases. It becomes maximum at a point. After if the wavelength increases, it becomes decrease. It starts decreasing. If I try to show you graphically, it will be something like this. Here is the wavelength like this. Where wavelength is small, intensity is maximum. This is how this axis should look like this. Got it? Wavelength is this one from here to here. Here wavelength is from here to here. So wavelength is this. So you have to think. This means this black body, which has been heated to a particular temperature T1, is capable of giving out radiations of this wavelength also, this also, this also, this also, this also. But there is a wavelength which is maximum. Let us say this is the maximum wavelength here. So आप कह सकते हो कि ये वाली wavelength जो है ये maximum है. इसको ले लो इसे. What does it mean? We have given you a black body, you have heated it. You can find its temperature, you have got a spectrometer, you can analyze the frequency. You know that the maximum wavelength is given this thing. Have you understood? Less of this and less of this. This is the characteristics of a black body. If they ask you what is a black body, you know the definition. What are the various laws associated? You can give these two laws. If you describe a black body spectrum at one temperature, you can say describe a black body spectrum at two temperatures. You will say this. Then you will say that the peak of the spectrum shifts towards the what? Lower wavelengths. आपको देख रहे हैं? If the temperature increases, lambda max shifts towards the lower. Means they are indirectly proportional. इसको if you just check it, then you can see the temperature is inversely proportional to 1 by lambda m. This you can say lambda m into t is constant Rees law, or temperature of a star is inversely proportional to its wavelength. This is the second thing.